Hello. So, the question you probably have on your mind already is uh, if a microcontroller operates on 3.3 volt, how do you switch a let's say outside light that uses to 20 volts? 3.3 volts is quite far from 220 volts, right? So we use what's called either relays or Mosfets for this. So how they work, uh, and these are pictures of a relay there. This one here, a typical board that you can buy. You hook up these pins to your microcontroller, and now suddenly you can switch things. And if you look there, you can see this specific one is actually a 12 volt relay. You want a 3 volt relay. Just for interest's sake, of course, you can buy them 3 volt, 12 volt, 24 volt, and so forth. But this one can switch loads of 10 amp to 50 volt. And the load is whatever you're going to connect to it. Is it a light? Is it a pump? And so forth. If it's a geyser, for instance, you want a much bigger relay, one that can handle more power. All right. And this, I know it's an ugly picture, but this, you don't get these type of relays anymore, but it explains exactly how a relay works. All this copper wire that's turned on a coil creates a magnet. All right, and how it will work is if you put 3.3 volt on this coil, it will create a magnetic field that can either pull something like metal closer to it or away from it. These two pins here is connected to your load, like your maybe a pump, right? So what will happen is once the magnet field is started, this pin here will push back from the magnet field, closing these two plates. That means now electricity will flow. So on this side you can have electricity. It's like a switch, like if you think of a manual switch, when you switch a light on and off, this works the same, but instead of you using your finger to do that, you use a magnetic field that pushes this two contacts together or apart. Now you also get what's called a MOSFET. This is the preferred way these days, where one of these legs, probably this middle one, will take the 3.3 volts of a microcontroller, closing this leg and this leg, where, for instance, the load can be a motor. So this can be the negative wire of the motor, and then a positive wire going straight to the motor. So the negative wire goes in here, and then will not go any further until there's 3.3 volt here, at which point it will close the connection and go straight to the motor. So that's how it works. That's how you take 3.3 volt and operate things that is to 20 or more even. All right. Now, what's very nice about a MOSFET is this pin you can use PWM on. So the pin will go faster and slower, and it will look sometimes that you might only have 1 volt on this pin because of PWM that takes that microcontroller pin and make it go open or on and off very fast, but more on or more off. See the video on analog and digital. And this then can create for you a dimming type of thing, because you need the full 3.3 volt to switch on this area here all the way. So you can, with a MOSFET, then control motors, and only a part of the volts or all of the volts to the motor can be applied, making a motor go faster or slower. That's it for this lesson. You now know how you can use 3.3 volt to work with high voltage applications. I will see you in the next lesson, and that will be the finale for microcontrollers before we start going into conventional programming. We're not going to do a lot. It's really the absolute that we require, and as you carry on, you learn more about coding. But let's look at breadboards next. It's done by one of my good friends. We work together a lot, so I stole his video to show you how a breadboard works and how you can do prototyping. I'll see you in the lesson after that. Bye.